Hello, everyone. We are Claire Mueller, Alex Wang, and I am Sebastian Ruhs. We'll be talking about Brazilian soccer tournaments, optimal game plan, and integer programming model. Just like in most other countries in the world, soccer is the most important sport in Brazil. But besides being an attractive sport, it's also an extremely lucrative business with TV rights and advertising time being sold for extremely high values. However, the level of attractiveness is different for each game. Games earlier in the season are less valuable than games later in the season. Games played on the weekends are watched by more fans than games played during the week, and certain pairs of teams that are playing against each other are more attractive than other pairs playing each other. So to maximize the profits and to maximize fair games requires a very complex scheduling system for all tournaments. Just to give a basic introduction of how Brazilian soccer tournaments work, there's an A series and a B series with the better teams playing in Series A. Each of both series consists of 20 teams, and each team plays each other exactly twice, so that comes to 38 rounds or 19 mirrored games. Further, there is a so-called G12. There are G12 teams, which consist of the 12 strongest teams, which don't necessarily all have to play in Series A. Most interesting games are those that include G12 teams, especially when G12 is playing each other. As already mentioned, games played on the weekends, as well as games among teams that are either from the same state, so-called regional games, or teams from the same city, so-called classic games. So to meet profit maximizing and fairness criteria, a set of a total of 5 main constraints with different or multiple sub-constraints need to be satisfied. So the first out of the 5 constraints is the round robin tournament. That means that each team plays each other team exactly twice, once at home and once away. And once in each, one game is in each of the 2 rounds. Games in the second rounds are played in the same order as the first round is being played in, but in opposite locations. That's so-called mirrored schedules. The second set of constraints addresses the home and away pattern. Teams in the same pair always play opposite home-away schedules. If teams from the same hometown play against each other, only one of those will be considered home. Teams that played away in the first round of the prior year and teams that upgraded from Division B are more likely to play the first round at home. During the first 4 rounds of the first phase and the last 2 rounds of the second phase, teams will alternate between playing home and away. Teams playing home in the first round will play away in the last round. Each team has the same amount of home and away breaks, but the number of breaks should be kept as low as possible. And each team plays 9 games at home and 9 away games in each phase. The third set of constraint addresses classic and regional games. As many classic games as possible are to be played on the weekends, because those games are very attractive and there are more viewers available over the weekends. Regional games should not be played during the first 3 rounds or the last 4 rounds, as those would interfere with the attractiveness or with multiple other games. If a classic game is played at Sao Paulo, then no games between G12 teams of Rio or of Sao Paulo are played in the same round. And the same applies to if a classic game is played in Rio, then there's no game of a G12 team of Rio or Sao Paulo played in the same round. No more than 1 classic game is to be played in each city during each round. No team can play classic games in consecutive rounds. And some teams Some games will have to be scheduled at specific rounds if requested by sponsors or teams. The fourth set of constraint addresses geography and G12 teams. No team with a home location in Sao Paulo can play more than 4 consecutive games in their home state. And conversely, no teams with a home location other than Sao Paulo can play more than 3 consecutive games in their home state. Each team must play out of state in either of the first 2 rounds. No less than 2 and no more than 4 games involving G12 teams are allowed in every round. No team can play more than 5 consecutive games against a G12 team. And the final set of constraint addresses perfect matching of paired teams. An example is if team A and B are in the same pair and C and D are in the same pair, then if A plays C at home, then A plays D away and vice versa. And Claire will continue with the integer programming model.
Thanks, Sebastian. Yeah, so the integer programming model is essentially taking the constraints Sebastian just talked about and putting them into Excel so that it can be solved, or another solving system. So since we have 19 mirrored games, what that means is that if the first 19 games are optimized, the second 19 will be optimized. So they're really looking to optimize those first 19 games. And then we also have to define all of our variables before we can put the model together. So here are a few. T is for the number of teams, H is all of the feasible home and away game patterns, L is the pattern of games, and K is a round. And then they stated that odd numbered teams would be assigned to home games first. That just makes it more fair to start that way. If we go to the next slide, Sebastian, if you can go to the next slide.
Sorry, I'm stuck.
No, you're good.
Hold on, I'm not sure why it's not moving forward.
That's
Sorry
okay.
for that.
We can just go this way. So here we're looking at our decision variables. And so the decision variables are what you would like to determine in order to optimize the objective function. So in this case, the objective function is, you know, making the most money, having the most competitive games. And so they're looking at home games and the overall game pattern. So if we look at, does a team play at home, in which round, it would be a 1 if yes, and a 0 if no. And then we're looking at team 2E minus 1. So that's just taking the team that would be like 4 times 2 minus 1 would be team 7. All of the teams are given a number. Does it follow the same game pattern as team 8? And if yes, the value is 1, and if no, it is 0. We can go to the next one.
Strange.
That's okay. We can just do it from this view, Sebastian. Yeah. That's fine. So Sebastian talked a lot about the geographic constraints. There are many in this league. So again, they're going to define all of the variables that have to do with turning those geographic constraints into mathematical constraints. And they use those to create the formulas for optimizing their model. All right, and then we can go to the next slide. So with the objective function, you're trying to maximize the number of classic games played in double weekends D, since this is the main factor driving ticket sales and TV viewership. So it seems like a basic kind of objective function. You're really looking for one main thing, but unlike with many of our in-class problems, we have 22 pretty complicated constraints that come with figuring out that objective function. So having that many constraints allows the league to, make themselves even more profitable by figuring out the exact optimal schedule for the teams. So in this case, they are stating that all of the constraints need to be met and they're all being treated as non-negotiable. So they don't have any constraints that are like, not primary constraints. You can go to the next slide. So this is listing out a few of the constraints from the model. There are a lot of them, but I just tried to pull out a few of the main ones. So one of these first constraints indicates that games between G12 teams, what Sebastian was talking about earlier, those top 12 teams, in each round, you need to have between 2 and 4 G12 matches. So this constraint ensures that you are meeting that requirement. The next constraint is saying that in the first 3 rounds of the tournament, the number of regional games, which draw smaller crowds, must be equal to 0. So this is taking the C is based on the city. And so it's taking the regional cities and saying that the number of games played in those cities in the first 3 rounds equals 0. And lastly is the integrality constraint. It indicates that the decision variable has to be a 0 or a 1, which in this case would mean they play the game or they don't. Otherwise, if you didn't have that, you might get integers and different numbers that might, well, you would get the opposite of integers. You might get decimals and things like that that wouldn't make sense in this case. And then with that, we can go on to Alex.
Thanks, Claire. Okay, for my part, I'll just mention some achievements of this scheduling software and the benefits of applying the operation research into the sports management. So after the coding the software using C++, we could validate the software with the data from 2005 and 2006 Series A gamings. The official scheduling arrangement used violated some regulations, and the number of breaks were far greater than the minimum value imposed by CBF, which is the official organization, whereas our software met all the constraints. And more importantly, the new approach allowed them to broadcast all 56 of the most attractive games, which indicate higher sales and higher profit. The system actually kicked off in 2009 as the official scheduling software. New criteria has been proposed and the process has been redefined. All these adjustments are well digested by our new system. And the champion was not known until the last minute of the game. The performance exceeded the audience expectation, maintained high public interest, and achieved large gate attendance. During 2010, the tournament is especially hard to arrange because of the World Cup and the attendance of all G12 teams, but the system managed to keep the fight of the titles in the last round, which led to high satisfaction among decision makers. So like many sports, soccer is very attractive because it's hard to predict in advance. For long tournaments, the schedule arrangement should make sure that all teams face the same level of difficulties and maximize attractiveness. That's pretty much all for our presentation today, and thank you for listening.